Hello, this is part one of limit practice problems. So we're gonna just practice limit problems. So if you, for any chance, forgot how to do limits, you can check out the videos for the different techniques for finding limits. So yeah, so let's start with number one. We got to find find the limit for the following example. So number one says find the limit as x approaches 8 of the polynomial x squared minus 5x minus 11. So what I would always do is try to, you don't want to get 0 over 0, right? That's our goal. So if you plug in 8 into the polynomial, this would be okay, so this doesn't give you 0. It actually gives you a 13. So that's good. So this one is an easy one because you just plug it in and then you get a number. So our limit as x approaches 8 is going to be 13. Okay, number two, find the limit as x approaches 3 of this rational function x squared minus 2x minus 3 all over x minus 3. If you immediately plug in 3, it's going to give you 0, 0. This is going to be 3 squared minus 2 times 3 minus 3 all over 3 minus 3. So that would give you 0 over 0. Okay, so we have a problem. So maybe what we could do is factor the numerator. So, and then maybe something cancels. So let's do that. So the limit. The numerator x squared minus 2x minus 3 can be factored out as x minus 3 times x plus 1. And then on the bottom, it's just going to be x minus 3. And what do you see that cancels? The x minus 3. So this cancels, this cancels. So your limit is going to be as x approaches 3. It's going to be x plus 1. Then when you plug in 3 into this, it's going to just give you a number. So that would be 4. Move on to number 3. What is the limit as x approaches positive infinity or infinity of this rational function x fourth minus 8 all over 10x squared plus 25x plus 1? So what I would do is I would divide each term by the highest power of the denominator, not the numerator, of the denominator. So if you look at our denominator, 10x squared plus 25x plus 1, what is the highest power? It is x squared. So this would be limit as x approaches infinity. And then this is going to be x fourth over x squared minus 8 over x squared. And then this is going to be 10x squared over x squared plus 25x over x squared plus 1 over x squared. Okay, and then go ahead and clean that up. X fourth over x squared is x squared minus 8 over x squared. 10x squared over x squared is just 10 plus 25x over x squared is x to the negative 1 or 25 over x. 1 over x squared is just 1 over x squared. Okay, Now, if when you plug in plug in infinity, this would be infinity square minus 8 over infinity square 10 plus 25 over infinity plus 1 over infinity squared. Okay, so infinity square is just infinity. 8 over a very large number over infinity square is going to be, so 8 over a very large number is going to end up to 0, so it's going to be minus 0. And then this is going to be 10 plus 25 over a very large number is going to be 0. And then 1 plus over infinity square, or 1 over a very large number, is going to be 0. So it's going to be infinity over 10, which is just going to be infinity. Okay, so that was that one. Let's move on to 4. Find the limit as x approaches 6 to the right. So this plus means to the right of this rational function x plus 2 over x squared minus 4x minus 12. So this one, you might need a little bit of graphing. It would help to graph it, because what I would first do is maybe factor if I can, because so on the top it's x plus 2, and then on the bottom it could be factored out as x plus 2 and minus 6, right? And the x plus 2 cancels. So it's going to be limit as x approaches 6 to the right of 1 over x minus 6. So what do you know? Remember, if you go back to college algebra, if something cancels x plus 2, in our case x plus 2, you have what's called a hole. So we have a hole at x equals to negative 2, right? Because x plus 2 cancels if you solve for x. If you set x plus 2 to 0 and solve for x, you get negative 2. Then to find the y value, you put it into this one. So it'd be that'd be 1 over 2 minus 6, which is 1 over 2 minus 6 is negative. It's minus 2 minus 6, which is negative 8. So you have a hole at negative 2, and then negative 1/8 is the same thing as negative 0.125. Okay, so that's kind of important when we graph it. So here's our new rational function. Yeah, let's try. I'm going to kind of briefly graph this. If you forgot, you could just put in Desmos. So, but first thing you need to do is find the vertical asymptote by setting the denominator 0. So our denominator is x minus 0, x minus 6. Set it to 0, solve for x. You get x equals 6. And then a horizontal asymptote is going to be y equals. This is bottom heavy, so it's going to be y equals 0. Okay. So if you kind of briefly, I'm not going to go too much in details because you should know how to graph this, but you can always put in Desmo if you're not sure. So vertical asymptote at x equals 6. So 1, 2, 3, 4, 5, 6. Do the dashed line. This is x equals 6. And then our horizontal asymptote is y equals 0. Maybe I should use another color. How about this one? So at y equals 0 is this line. And then when you test points, I'm just going to tell you that on the right hand side, it's going to look like this. Because you would test a point, right? Like 7. And then on the left hand side, well, we have a hole at negative 2, comma. So we have a hole right about here, right? And then on the left-hand side, it's gonna approach like this. Okay. Okay, so now let's figure out what is the limit as x approaches 6 to the right. So here's 6. And then remember, a limit is a y value. So 6 to the right, it just shoots up straight up, right? So it's going to be positive infinity. And then if you're curious, 6 to the left is actually 6 to the left, 6 to the minus is actually going to be negative infinity because it shoots down. So that is our final answer. It's just going to be positive infinity. Okay, number 5. Limit as x approaches 7 of this rational function. Well, if you plug it in immediately, you're going to get 7 squared minus 49, which is 7 over 0, which is undefined, right? Okay, so the correct answer is undefined, or DNE does not exist, and I'll show you why it doesn't exist. So in order, let's figure out one-sided limit. So let's figure out what's the limit as x approaches 7 to the right, and then what is the limit as x approaches 7 to the left. If the limits are not the same, then it does not exist. Okay, so what should we do? Well, maybe it's a good idea to figure out what the graph looks like. Well, so we're going to figure out, let me write this out, limit as x approaches 7 to the right. And then the limit as x approaches 7 to the left. And then yeah, so you would do is kind of graph it. So what do we know about this graph? We have if you FOIL the bottom, nothing cancels. So you don't have to worry about any holes, but let's find our vertical asymptote. So you set the denominator 0 and solve for x. So our denominator is x squared minus 49. Set it to 0, solve for x. So add 49. And then when you take the square root, you're going to get two vertical asymptotes at 7 and negative 7, right? Because when you take the square root of 49, you get two answers. And then what's our horizontal asymptote? Horizontal asymptote is y equals, it's going to be y equals 0 because it's bottom heavy. So you could just put this in Desmo, but this is what the graph should look like. One, two, three, four, five, six, 7. 1, 2, 3, 4, 5, 6, 7. And then vertical asymptote. And then okay, so it's gonna look like this. Oh, don't forget you have a horizontal asymptote at y equals 0. So yeah. Okay, so on the right-hand behavior, it's gonna look something like this. And then in the middle section, it's gonna look something like this. And then on the further left, it's gonna behave like this. And then yes, so what So let's figure out what's the limit as x approaches 7 to the right. So here's 7, and to the right, it just shoots up to positive infinity. And then 7 to the left here, I mean, yeah, 7 to the left. Here's not -7, but 7 to the left. Here's 7, and to the left, it shoots down to negative infinity. So remember the one-sided limit rules. These two limits has to be the same in order for the limit to exist. So that's why these limits are two different values. One is positive infinity, one is negative infinity. So this is why it does not exist, D and E. Or you can also say diverges. Let's move on. Okay, so this one we have what's called a piecewise function, because you see we have two graphs. One is a parabola, one is a linear. So what I would do is just I would graph each one individually. Yeah, so let's graph this one. So f of x equals to x squared minus 5. Well, let's figure out what the y, they said our boundary is less than or equals to 3, so let's figure out what our y value be when x is 3 for this function. So f of 3 is going to be 3 squared minus 5, which is 9 minus 5, which is 4. And then what's next? You would find, we have a y-intercept at -5, right? So if you plug in 0, you would get -5. So you have a y-intercept at 0, -5. And then maybe we could plot the two x-intercepts. So we have, you set to find the x-intercept, you plug in y to 0. So it's going to be 0 equals x squared minus 5. And then when you solve for it, you're going to get radical 5 and negative radical 5, which is about, what is radical 5? That's about 2.2. So this is 2.2. This is negative 2.2. And yeah, let's graph that one. So what this graph would look like, just for the top one, not the bottom yet. Oh, I'm so sorry. I didn't ask, they're not on 6, they're asking two things. They want to know what is the limit as x approaches 3, positive 3 to the left. And then part B is the limit of f of x. And then the limit as x approaches 3 to the right of f of x. And then just the limit in general of f of x. Okay, so yeah, so I'm just going to graph this part really quick. So we have, let's see, we have a y-intercept of -5. One, two, three, four, 5. And then what else do we have? We have a point at what is it? 3, 4. Now, because it has an equal sign, it's going to be a dark circle, so we have to include it. And we have two x-intercepts at 2.2 and negative 2.2. So it would look something like this. So you're probably asking, why doesn't the right side have an arrow shooting up? Because our boundary, it says less than equal to 3. So we stop here. So we only care about the left side. And then we have to include a dark circle because it says equal to. Okay. Now let's graph the linear function. So let me use another color. How about right? So let's graph f of x equals x plus 2, where the boundary is x is greater than 3. So that is a linear line. And what do we know about this line? So well, let's figure out what the y value is when x is 3. That would be 3 plus 2, which is 5. So we have a point at 3, 5. And what else do we know? We know that we have a y-intercept of 2. So we have a point at 0, 2, and then we also have a slope of 1. So 2, and then another one at 3, 5. 2, 3, 4. Now 3, 5, it says it's greater than equal to it's going to be an open circle because it doesn't have an equal. So it's greater than 3. So it's going to be right here. And then we have a y-intercept of 0, 2. So our slope is 1. So you could go up 1, right 1, up 1, right 1. And then again here at up 1, right 1. Okay, so the thing is, we don't care anything about the left side because it didn't say less than, it says greater than. So we only care about everything on the right. So this is what we care about. Everything else does not matter. So let me erase these dots. Okay, so this is our piecewise graph. Now, based on that information, can you tell me okay, so based on that piece of information, can you tell me the limit as x approaches 3 to the left? So here's 3, and then to the left. So remember, it's the y value. So 3 to the left is this y value, which is at 1, 2, 3, 4. So this is 4. And then what is the limit as x approaches 3 to the right? So here's 3, and to the right, it's going to be this y value, which is at 5. And then the limit of f of x as x approaches 3. Now, it's going to be DNE, right? Does not exist because these two limits has to be the same in order for it to be that limit. Since these are two different y values, it does not exist. Okay, let's move on. Let's do limit of x approaches pi over 4 of 3 cosine of x. So maybe if we just plug it in, we might get an answer. So this would be 3 and then cosine of pi over 4. So cosine of pi over 4 is radical 2 over 2 times it by 3. So that's 3 radical 2 over 2. Okay, it's not 0, so we can use that number. Whoop, wait, my bad. Did I make a mistake? No, right? Cosine of pi over 4 is radical 2 over 2. Yep, that is your correct answer. I just thought something canceled. Okay, nothing cancels. Okay, number 8. Find the limit as x approaches 0. Maybe if we try plugging it in. So this is 3 times 0 over cosine of 0. So 3 times 0 is 0, and then cosine of 0 is 1. Now, this is okay. 0 over 1 is actually 0. We don't want to have undefined or 1 over 0, right? So this is fine. So your limit would be 0. Number 9. What is the limit as x approaches 0 of 3 of x over sine of x. This one I'm going to use my special trig limit. If you forgot about the special trig limit, there is a video I made. And then we're going to use this rule. The limit as x approaches 0 of x over sine of x equals to 1. So this 3 is a constant. So you can say limit as x approaches 0 of 3 times x over sine of x. So we know that this x over sine of x is going to give you 1. So this is like saying 1 times 3, which is 3. Okay, so that's number 9. We're almost done. I think there's like 2 more problems. The limit of tan of 7x over sine of 5 of x. So what I'm going to do is simplify this, the numerator. So tan of 7x is equal to saying sine of 7x over cosine of 7x all over sine of 5 of x. So we have a complex fraction. So this is equal to saying sine of 7x over cosine of 7x divided by sine of 5x over 1. And then if you cross multiply, that would be sine of 7x. And then this would be sine of 5x times cosine of 7x. And what can we do? So that your new problem is going to be limit as x approaches 0 of sine of 7x over sine of 5x times cosine of 7x. I'm going to use this special trig rule. So I'm going to use, there's 2 trig rules I'm going to use. So the limit of x approaches 0 of sine of ax over sine of bx. It's just the coefficient, so it would be a over b. And then I'm going to use this rule, the limit as x approaches 0 of cosine of x equals to 1. Okay, so this we're going to, so if you simplify these two, sine of 7x over sine of 5x is equal to just using the coefficient. So that's like saying 7 over 5, right? And then cosine of 7x is going to use this rule. So that gives you just 1. So that's like saying 7 over 5, which is 7/5. A few more. Yeah. So number 11, limit as x approaches to 0 of sine square of sine of x over sine square of 11x. So I'm going to rewrite this problem as the numerator can be written as sine of 7x times sine of 7x. And then on the bottom, it's just going to be, the bottom can be written as sine of 11x times sine of 11x. So we're going to use the coefficient rule. So we're going to use this rule, limit as x approaches 0 of sine of ax over sine of bx equals the coefficient. So yeah, so this is a quote. So this is like saying this one here is going to be 7 over 11 times, and then this rent here is equivalent to saying 7 over 11, which is going to be 49 over 121. Okay. That's number 11. The last one. Limit as x approaches 0 of 3 plus h squared minus 9 all over h. So maybe if I simplify the power, simplify this. So this would be 3 plus h squared is going to be h squared plus 6h plus 9, and then minus 9 all over h. So the 9's cancel, so you have the limit as x approaches 0 of h squared plus 6h all over h. And then you could actually take out an h, so that would be limit as x approaches 0 of h times h plus 6 all over h. And then the h cancels, so you're just left with the limit as x approaches 0 of h plus 6. And then when you plug in x for 0 for h, that's just going to be 0 plus 6, which just gives you 6. Okay. I hope that helps. So yeah, that's the last problem. Okay, thank you. Have a good day. Bye-bye.